Hey, can you make my weapon look better? It looks dull. It's just a gray chunk of metal with a glowing material slapped on top.
Sure, we can improve it with a shader.
A shader? What's that?
Let me show you something. See that water over there?
Yeah, the waves look pretty cool.
The water is a great example of what a shaders can do. A shader is a program that tells the graphic card how something should look on the screen. Without shaders, object would be very simple, but shaders can create all kinds of visual effects. For example, look at this water. The shader can make the waves move, control the colors and the reflections, create transparency, and make the surface feel alive.
So, the water isn't actually animated?
In many cases, no. It is just a simple mesh with a shader doing the heavy lifting behind the scenes.
That's crazy. What else can it do?
Shaders can do much more than that. They can affect lighting, movement, transparency, glow effect, and countless other visual features.
So, if shaders can make water look this good, they can make my weapon look better too?
Exactly. We can make it glow at magical energy, create animated patterns, make it look molten, icy, corrupted, or anything else we can imagine.
Now you've got my attention. How are shaders created?
Traditionally, shaders were written in code using a language called HLSL.
HLSL.
Yep, just like we write gameplay code in C#, graphic programmers write shaders in HLSL.
Oh, come on! Another programming language. That sounds like a lot of work.
Don't worry, we're using URP.
And?
URP gives us shader graph, which let us create shaders visually by connecting nodes together.
Wait, no code? It's too good to be true.
For most effects, no code.
So I can make glowing weapons, magical effects, animated materials without learning HLSL?
Exactly.
Why didn't you start with that?
Because first, you needed to know what a shader is. In the next lesson, we'll open shader graph and build our first shader from scratch.